your stock standard strategy for approaching a question that you don't really know what to do with yet is to start from what you know and then just do some work on it. Like, you're often surprised by how much, as you just start to push on it, it's like, oh, something's appeared, and now I can take that and run with it. Okay, it wasn't immediately obvious, but if I can sink my teeth in it to begin with, then, well, maybe something will emerge. So let's have a look at this. I know this, right? I don't know this, so I don't really want to use that as like my basis to build off. I want to use that as where I am, right? So here's where I'm going to begin. Now, when I look at this, the only thing that jumps out at me is to expand. It's the only thing that I can obviously see to do. So let's give it a shot, see what happens. I'm going to get, do the pairing up of the terms. So it looks like I get 4ab, yeah, minus 2ax. You happy with that? I got take away 2bx and plus x squared because of the double negative. Yep, happy so far? That's that, okay? Any suggestions? Now what?
Get rid of the x squared.
Okay, good. Same guy on both sides, so let's just clear him off. So, gone, gone. As I do that, I can see there's something else I can easily do, namely that all these coefficients are even, right? So I can just divide through by 2. You happy with that? So I have a 0 over here. Then I've got 2ab, take away ax, take away bx. Okay? Not too bad. Anything else you can see that I could do from here? I could potentially solve for x if I wanted to. I could solve for x. I could get these x terms over here on the left, like so. And then what would I do here?
Factorize.
I can factorize.
And then move the unrelated to the x part to the other side.
Good.
And you get the
Okay.
off the thing.
Yep, is that okay? Now, I look at that, everything I've written is correct. There's no problems as far as I can tell, okay? The only problem with it is it's gotten me nowhere in actually proving this, right? So this is all true, but there's nothing that immediately connects with this, right? So does anyone have any suggestions for me? Yeah, Doris.
Could you try and make that something like 1 on b minus 1 on x equals 1 on x?
Okay, so a great way to go is, if this is an AP, right, and these are the terms I've got, none of these terms have appeared anywhere here, but I ought to expect that they should somehow, right? That's exactly right, and they will, in fact, okay? However, I'd probably like to say, at least me, when I looked at this question the first time a while ago, it didn't jump out at me at all. You can do something in one fell swoop, but it's not immediately obvious, okay? But we will. That's a great idea. Someone want to give me another suggestion?
Take the am of, let 1 on x be the am of 1 on a plus 1.
Okay, so now I'm going to, in case you didn't hear Ralph's suggestion, anyway, the suggestion was to talk about the AM, the arithmetic mean. If this is an AP, right, if it really is an AP, then this should be the AM of this. Yeah? That's true. That's exactly true. My only problem with saying that is I don't actually know that that's true yet. I'm trying to prove that. Okay. What would that look like? 1 on x should be equal to... Now, how do I work out the arithmetic mean of these two numbers? I would add them. I'm taking the average, aren't I? So I'm going this plus this, and then I divide by 2. That's taking the average. Okay. Now, you have a look at this. How is that connected to this? Okay, so you can see here I've got 1 over x, but here I've got x. I have a point of contact, right? So if I take the reciprocal of the left and the right, like so, I'm still not there yet, but I've got a promising sign. I've got that 2 there, right? That's good. What am I going to have to do over here on the right? Now there's a fast way and there's a long way, okay? Let me suggest to you the quickest way. Remember we said, oh, this is really good. I've got a 2 there and I've got a 2 there. That's great. What am I missing on this numerator?
AB.
I'm missing AB, aren't I? So clearly it would be useful if I had an AB here. Now if I'm going to multiply this by AB, well then you better multiply the denominator by AB, right? 2AB, what's 1 on A times AB? What's 1 on B times AB? Okay, so I'm there. Now I haven't proved it. I've just mapped out for myself a path, right? It wasn't immediately obvious where I could go from here, but now that I see where I'm supposed to connect to, all right, what would you like me to do on the left-hand side?
Divided by AB.
So I can literally do this in reverse, right? So I can say, excuse me, if I divide the top and bottom by AB, like that, I just end up with a 2 there. And then this turns into 1 over B. And this turns into 1 over A. Now I've got next there. Okay, now what?
You do a ring.
Now you reciprocate.
Yeah, that's right. At this point, I was like, oh, I needed to flip things over. Okay, so I've got 1 over X equals, I might as well put these guys in the right order. That. Kind of finished. Now, I will say, this was not immediately what I thought of doing. It's fine. It amounts algebraically to the same thing. However, the AM is kind of like it's a kind of proof. It's a kind of proof. It's not our definition for what an AP is. We've got a definition for how to prove an AP is an AP, and we've also got a definition of how to prove a GP is a GP. What's the definition? Why can't I sub this into where? That? Into where?
1 over X.
You can.
Is that what
I asked for suggestions, but this is the first suggestion I got, right? So, okay, I'll come to yours in a second. Right? I don't know if that's necessarily quicker, though. Remember, Mincy, were you going to give me a definition? Or were you going to a test? Or were you going to give me something else?
proving this?
Yeah, how do I prove it?
T3 minus T.
Good, yeah. T3, take away T2, right? Right? Should be equal to T2, take away, yeah, there you go. Okay. Now, by the way, this ends up being exactly the same as this, because saying that is just like saying it's the arithmetic mean. Let me demonstrate it for you, right? Excuse me. See how there's a minus 1 over a here? I'm going to add it to both sides. So that gives me 1 over b plus 1 over a. There's a pesky 1 over x here that I might as well collect like terms over here. So that gives me 2 over x. Does this look familiar?
Mm-hmm.
Doesn't it? Like once I divide this through by 2, there's my 1 over x, and there's my 1 over a plus 1 over b on 2. It's the same thing. They're all saying the same thing. Okay? Different paths up the mountain. Yeah.
You have to like assuming that is an arithmetic mean.
Correct. So I've kind of assumed this definition in here, which I think it's better probably. It's more watertight to go with this because that's literally the definition of an AP.
So if I started with that first line with that one, and then I led to it equally being equal to 2a and b on b plus a, and that one is already equal to 2ab on b plus a. Do I just say because they're equal, I can prove it?
I wouldn't do it that way. So everything I put here in red and green, it's kind of like just my thinking space, right?
Yeah.
It's what I've resorted to when this didn't become like, oh yeah, I know what to do, right? So I thought, where else can I go? But what I would do is if I take this, this is actually, I think this is the most watertight way of doing it, is at this point over here, let me look, where's the point I wanted? Here. Okay, so what I would do is I'll say, oh, okay, now I know where I can take this, right? I'm going to say, okay, I'm going to divide everything through by ABX. I'm just going to write that there for my own sake, okay? The reason why I know to do that is because I'll get my over X over A over B, right? It's kind of like the reverse of doing the lowest common multiple. So this is going to have A and the X are going to cancel, like that. The B and the X are going to cancel, which gives me that. And then the A and the B are going to cancel, which gives me this.
How do you think?
Do you see that? Now, stop. How did I think of it? I knew to think of it because I'd written this before. I knew it was going to go there, right? And so I can see, oh look, there's where the 2 is. It should correspond to that 2 over there. Like, where else can it come from?
So you're just assuming that it's true.
I haven't assumed anything on this black line of reasoning.
No,
I've assumed nothing.
No, you've assumed that it should get.
Are you discontent? Shall I finish it? You agree with that? And now I just need to rearrange. Term 3 minus term 2 equals term 2 minus term 1. I'm done. Definition. Okay? I prefer that because it's the definition of an AP. Therefore, is an AP. But as you can see, like by all the lines of working in different colors, they all mathematically amount to the same thing. Okay, so I think probably all of them would get a pass and get a tick. Yeah.
So you know how you worked in green and red